Hello friends, welcome to our channel Cisco Packet Tracer Labs, where we bring networking concepts to life. In today's practical, we will learn the concept of dynamic routing. Launch Cisco Packet Tracer, go to networking devices, switches, select 24 port switch. We are going to use three networks, so put three switches over here. Go to end devices. For simplicity, we will connect two end devices in all the three networks. Connecting the PCs with the corresponding switches. This is our network A. With network address 192.168.10.0. Similarly, this is network B with network address 192.168.20.0. And this is our network C with network address 192.168.30.0. In network A, to PC0, we will assign IP address from the range of network 192.168.10. Let it be 10. Gateway, okay. You can take it 11. Gateway address will be 192.168.10.1. Similarly, we will assign the IP addresses to all other PCs. In network B, it will be 192.168.20.1. In network C, it will be 192.168.30.1. In the next step, we are going to connect routers to the given networks. In our example, we will take three routers. We will take PT router, place one PT router over here, take another PT router, let us put over here, and one more PT router, putting over here. Now we connect the networks A, B, C with the corresponding routers. First of all, let us make our scenario a little bit colorful by demarking the networks. Now take a straight cable, connect switch 0. Students, please go step by step as I am doing, uh, because in the beginning the chances of making mistakes are more while assigning addresses to the ports. So go to switch 0, take any fast Ethernet port and go to router and select fast Ethernet 0 by 0 port. Now for the ease of operations, go to options, preferences, always show port levels. Now it will be easy to assign the addresses. Now you can see in network A, my gateway address was 192.168.10.1. Copy the address and assign the same address to this particular port of the router, which is FA 0 by 0. Go to router, configure FA 0 by 0. First step, turn on the port status, then give write the gateway address over here, and now you can see your network A is connected with the router 0. Similarly, take a state cable, go to switch network B, switch fast Ethernet port, and in our practical we will connect it to the same router, router 0, and connect it with the fast Ethernet 1 by 0. Now configure router 0, go to fast Ethernet 1 by 0 and turn it on. Right here, gateway address of network B 192.168.20.1. Now you can see our network B is also connected with the router 0. This green signal shows that it is physically connected. Similarly, we are going to connect network C with router 2. Fast Ethernet 0 by 0 and go to fast Ethernet 0 by 0 and connect it. Go to router 2, configure fast Ethernet 0 by 0 and turn it on. Right here, gateway address of the network C 192.168.30.1. Now in this way, all our networks, three networks are connected to the corresponding router. Now, next step is to connect the three routers with each other. So first of all, we will connect router 0 with router 1. Now to connect routers, we always use serial DCE cable, and serial DCE cable is connected through serial ports. So go to router 0, take serial 2 by 0 over here and router 1 and put serial 3 by 0 over here. Just stop now. First assign the IP addresses. Now we see there is one network between router 0 and router 1. Let us name this network as 10.0.0.0. Okay, this network is 10.0.0.0. We can make some marking over here to differentiate it. So this is router 0 and router 1. They are having one network which is 10.0.0.1. Now you can see serial 2 by 0 and serial 3 by 0. They are the part of the same network. So go to router 0, go to router 0, go to serial 2 by 0 port, switch it on and assign one address 10.0.0.1 to it. And similarly go to router 1, configuration, serial 3 by 0, switch it on and write here 10.0.0.2. Make sure that you are assigning the range of addresses to the ports which are connected to this network. Now we are going to connect router 1 with router 2. Again take serial DC cable, go to router 1, serial 2 by 0 port, connect it to serial 3 by 0 port. Okay. Now you can see serial 2 by 0 port is connected to serial 3 by 0 port. Now again, we are going to demark it with some different color to make the network distinguishable. So we will see router 1 and router 2, they are having one separate network, which is, we can name it 20.0.0.0. Router 1, go to serial 2 by 0, switch it on, assign the IP address 20.0.0.1, and similarly go to router 2, serial 3 by 0, switch it on, assign address 20.0.0.2. Now, till now, we have done the same thing which we were doing in the experiment of the static routing. Networks are connected. If you see, try to move the packet, take simple PDU, click on PC0 and then click on PC2. It will show you the failure. Let us try it again. PC0 and PC2. It is successful. It is successful because network A and network B are the part of same network. There is no need to provide routing in this case because they both belongs to the same network, same router. Now if I try to send packet from network A to network C, you try it again and again, it will always show you failure because of the reason, because it is not getting the packets. Let us see in the simulation mode. Go to simulation mode, show all oblique none, edit filter, ICMP protocol. Let us send the packet from network A to network B. You will see packet is moving because no path information is required on the way. The packets are the part of the same router. Okay. But now if I send the packet from PC0 to PC4, you will see once the packet reaches to the router, it does not get the path further. Here comes the role of the path. Now we have to provide the routing. Click on the real-time mode. Now to provide routing, as we did earlier was a static routing. Static, I always say in the class, S for static, S for small network. S for static, S for safety concerns. So where safety concern is there, where small networks are there, we use static routing. But when we are having a large and complex networks, we cannot provide static routing. We have to go for the dynamic routing. So let us do the dynamic routing part. Click on the router 0, go to routing, go to RIP. It is not rest in peace. It is routing information protocol, which is one of the type of dynamic routing. And but simply what we have to see to this router 0, we can see we are having three networks which are directly connected. 192.168 network A 10.0, network B 192.168 20.0, and this network 10.0.0.0. Simply write all these three networks over here. Write here 10.0.0.0 and click on add. Similarly, write here 192.168.10.0, click on add, and write here 192.168.20.0 and click on add. Now this is a routing table which is having 10 all the three networks which are directly connected to this router. Now go to router 1, RIP, routing information protocol, connect. We can see there are two directly connected networks. So I write here 10.0.0.0, add, then here write here 20.0.0.0 and add. Okay, close this. Now go to router 2, RIP. We are having two networks which are directly connected over here. One is 20.0.0.0, add. Another is 192.168.30.0. Now we have provided the routing information to all the routers. Let us check the connectivity between the two networks. Take simple PDU, go to network A and try to go to network C. We will see failed. So do not worry, I always tell you in the class that this is similar to math. Multiple attempts through hard work. Now let us do it again. Take simple PDU from PC 0 to PC 4. It is successful. We can see the connectivity in simulation mode also. Go to take simple PDU from network B to network C. We can see the progress. Packets are moving. All the three scenarios are moving simultaneously. We delete it and restart again. Go to PC2 to PC4. Packet starts. It goes to router, looks for the path, then looks for the path. It again looks for, go to network C. So in this way, our communication is successful. Thank you friends for watching the video.